Hello. My name's Terrence, as Kami-san said, and I basically work on Ruby stuffs for Heroku, so I make sure Heroku can run Ruby applications on the platform. I also wear this blue hat everywhere I go, so I've been wearing it almost every day since 2006. And as I've gone around conferencing, we've formed this blue hat team, so taking pictures of people have had this hat. So I know today is Saturday in Japan, and I think it's not actually Friday anymore at any point. But I have this tradition of going to conferences and doing Friday hug photos, so if you're not familiar, you take a picture of yourself hugging the camera. I think it's a tradition started by Aaron from years back. I don't know why he's like face palming. So if you guys would help and stand up and do a Friday hug, that would be really awesome.
簡単とか大丈夫だと思うんですけど、フライデーハグやりたいから買ってください。アロン来て、フライデーハグだ。
Hello. All right. So if you just look like the people in this photo, good. All right, let's go.
Happy Saturday.
Happy Saturday. Thank you. Happy Saturday. So I wanted to, Matsuda talked to me at asakusa.rb, and I realized a lot of people use Bundler. How many people here use Bundler in Japan? So it's a good amount of people, and I realized a lot of people don't necessarily know, in general, these people who work on the software that we use every day. I know this is true in America as well. Like, don't know people who work both in Ruby core and the language as well. Like in Zach's talk about nobody knows Nobu. This is Andre Arco. He leads and runs the Bundler team nowadays, and hails from San Francisco. Travels around the world speaking, works at Cloud City doing consulting, and then also on his free time works on Bundler stuff. This is Jessica Lynn Suttles. She recently moved to San Francisco this year, and she's helped this past summer with Rails Girls Summer of Code, mentoring and coaching people to contribute to that project for Bundler specifically, as well as helping with documentation patches and other bug fixes. This is Larry. He works mostly on server side stuff, so he has been working mainly with performance monitoring and maintenance of the servers that we run for Bundler. This is Tim. Tim recently joined the core team. He comes from Australia, and he's been a big help with both issue triage of stuff on GitHub and also fixing issues and working on features. It's been immensely helpful. And this is Smit from India. If you guys have used the new Bundler 1.6 with the faster resolver, this was his work. He is the one that rewrote the resolver and has been working on optimization patches for Bundler so we can all have faster dependency resolution. So we also are looking for new people all the time, so maybe one of you would like to come help and contribute to the Bundler project. So Bundler, if you are not familiar with the project, it's a dependency management library for Ruby. Just real quickly, you have a gem file and you specify basically all the dependencies in your application. And then you simply run bundle install and it'll go and fetch all your dependencies for you and print out a gemfile.lock, which will have the graph resolution of the result set. And so today I'm gonna mainly focus on, I guess, like how bundler gets that dependency information and some of the performance work that has been done to make that faster and better. So first I'm gonna talk about the modern index, like that's where it all started with bundler 1.0 and Ruby gems. And then the dependency API that was then built after that, and then this new index format that we've been working on over the last year that we're hoping to roll out this year that will improve and hopefully solve all the problems that is currently in the infrastructure that we have today. So if you aren't familiar with the modern index, this is used by both Ruby gems and bundler. It's simply a Marshall gzip file, and I did this morning, I think, when I pulled it down. So this contains all the gems and gem versions of everything on rubygems.org, and it comes out to about 1.7 megabytes. Back when with bundler 1.0, when it was considered really slow, a lot of people thought that it was the size of this file and fetching it that made bundle install really slow. But as you can see, 1.7 megabytes is not necessarily a very large file to fetch on a decent internet connection. And if we go and examine what's inside the file, it's just an array of these tuples of the gem name, the gem version, and then the platform that it's running on. So the first problem that you notice with this file is that it doesn't actually have any of the dependency information. So just given this file, we can't actually do a resolve because we don't know what any of the gems depend on. So we actually need to go back to rubygems.org and then fetch this gem spec file, which is this zipped Marshall file, and we can again unpack it and load it, and we see that this is the file that actually has the dependency information. So if we call the dependencies attribute, there's an array of these gem dependency objects that tell us what each gem depends on. So the other problem, so now that we actually have the information to do the dependency resolution, the problem is if you load the whole index into memory, it's essentially, since it's a Marshall file, it's literally every Ruby object that represents every gem of every version that has ever existed on Ruby gems, and you're loading into memory. So if you had like a VPS box back in the old Rails 2-3 days, and you tried to use bundler, it was pretty common to have only 256 megabytes of RAM. You would actually start swapping because it would take up so much memory. So there was definitely major problems there. And then there was this other problem that was really slow to run. So there was this XKCD comic that was edited to switch compiling for bundling for an interpreted language. And so people would just go and check Reddit or Hacker News or something while they were waiting for their bundle to install. Again, this is because the dependency graph, or the potential dependency graph that you're going to generate is really large in scope because it includes everything. So when you are trying to scope it down and do the back jumping, it has to look at many, many possibilities. So just doing bundle install on Sinatra using the modern index takes about 18 seconds in the US, which is not very fast. So a few years ago, the RubyGems team built this dependency API for us to try to make this faster. And it's a simple endpoint that you pass essentially this comma-separated value list, and then you get this result back. So it includes, again, the name, you have the version, and then you have the platform, as well as the first level dependencies for that gem. So you now have all this information, and if we go and look at the modern index, we can kind of analyze what this actually gets us. So the dependency information, that problem is solved now because it's included in the API information, and this is the main problem it was trying to solve. It consumes a lot less memory because the result set that you're getting back doesn't include gems that you're not interested in anymore. So if you're only interested in Sinatra and you're not pulling information from Nokigiri or Psych or RSpec or something, that's not going to be included in the result set. So you're not loading as many objects into memory. And since the result set is significantly smaller as well, when you actually go and do the resolve, when you do back jumping, you're not going to be jumping through as many like dependencies that just aren't like part of the solution set that you're going to look at. So in the same case, when I benchmarked in the US, it was about a little over 3 seconds, which is significantly faster than the about 18 seconds from before. So this wasn't a silver bullet. It didn't solve all the problems. It was better than what we had with the modern index, but it definitely wasn't the complete answer. So the first thing we found out was that it wasn't very cacheable. So if you look at the API endpoint, you can essentially pass an arbitrary list of gems. And so you imagine you have a gem file for your Rails app, and someone else has a different gem file that has a completely different set of gems. And even things commons like rack and Rails and like the common default gems. The result set that is actually being returned back for each of you is totally different. So we can't actually cache the HTTP response there. And the other statistic that we found out was that every 5 minutes, this was true a year and a half ago, that there would be a new gem version that is pushed up. So when this happens, you would have to invalidate the cache of anything that contains that gem. So it starts to become this tricky problem of making sure the result sets that we are generating are being returned back accurately. So whether you're trying to cache the HTTP response or you're trying to cache like the objects locally in a day store, it became a very hairy problem of trying to return the correct response back for caching to get speed performance. The second problem was that, so this was all backed by a Postgres database. And this is the query that we'd run. It includes 2 left outer joins, and there's a nested select in there. And you're essentially trying to solve a graph database problem on a relational database. And for the most part, it works okay, but when it does chug and run into problems, it kind of cascades and affects basically all the other requests as like the web server is waiting for the Postgres database to return the result back. And then we have to essentially kill off the queue and kind of restart the web servers. And the third problem with this is now we've moved away from static. So the monitor index is a static file that you can go and download. And we've now moved away from that. And this means we have to run and maintain a service. So this whole thing is run by volunteers who aren't paid to work on any of this really at all or do it, but we all on the team wear pagers to run this service, so when things do run into problems, we can go in and investigate or restart the servers or fix them. And the other problem from a global perspective is that the servers are running in US East, so that means if you're in Japan or in Europe, like you have to go many hops to actually get this API server. So on a global scale, it's not necessarily the most scalable solution either. So having like examined all these problems, we went back to the drawing board and talked with the RubyGems guys, and we came up with this new index format that will hopefully solve the problems that I just talked about of the first 2 solutions going forward. So this new index format contains basically three types of files. There's this names.list, and what it is simply a single text file where each line represents a gem, and you have a line for every single gem in the index. And then you have this versions.list, which is similar. You have basically a new line for every gem, but on the right side, separated by a single space, you have every version for every gem, and also all the platform versions as well. And then you have this deps folder, and inside the deps folder, you have a file for every single gem in the index that you're interested in. So if, for example, with Nokogiri here, if you're interested in Nokogiri, you would have this file, and it would list every version on the left-hand side. There would be a space, and then there'd be every dependency for that specific version, including both Ruby dependencies or RubyGems dependencies there. So the benefits of having a format like this is we can increase the, even like not talking about network anything, just the local performance. So just looking at the file sizes, if we just look at the deps folder, and we counted the size of all those files of everything in the RubyGems index. This was done like 8 months ago. It's about 202 megabytes. And if we take all the Marshall gem spec RZ files that we needed for the modern index, that comes out to about 1.1 gigs. And then if we go further and gzip these files, it goes down to 2.7 megs versus 20. So as you imagine, actually downloading all these deps is not necessarily that large if you want to replicate the whole thing and mirror it yourself. And then when we went through and started to benchmark loading these files into memory to see what it takes to load this information, using the modern index, it takes about 0.858 seconds to load all the gem specs into memory. And then with the new index format, it takes a pretty similar time as well, about 0.838 seconds to load all that stuff in, all the deps files. But the huge benefit is we can actually just load individual files that we need. We don't have to load everything including in the index. So you can get down to like 0.1 to just load the specific files that you need there. The other benefit is since we're dealing with individual files here, we can cache over HTTP the result sets. And then we only return basically the ones that you're interested in. And then because we're moving to static files, we started looking last year at moving over from CloudFront to Fastly, so like a more dedicated CDN that is interested in it. And the benefit here is that it has a bigger global reach, so there should be a Fastly instance that is much closer to your local region than what we were using before. So Larry actually sent a gist out when we were looking at this last year, and people basically ran this script to do benchmark performances. And I was combing through the data for this talk, and I was looking at just downloading the modern index from Japan. There was someone who returned something from Hiroshima. So if we look at from CloudFront S3, it took about, on average, 5.3 seconds to fetch this data. And so the initial hit to Fastly, you have to warm up the cache, and that took about 3.7 seconds. And then if you average just the hits after the cache has been warmed, it's only about 0.5 seconds. So it's about an order of magnitude performance increase moving over to Fastly. So this is like out right now. So fetching things from RubyGems should be significantly faster than it was not too long ago. In addition, with the files being static, we can cache them all locally. So you can have all the data, like if you don't have network, potentially you can do a resolution without actually hitting any of the network data. So when you're on like an airplane, if you actually have the .gem files, that should work pretty quickly. The other thing we're doing is we've implemented e-tags for all these files. So it means that if you're hitting the data and say a new gem gets pushed up, you don't have to re-download files that are already up to date. You only have to download the ones that are new and updated. So this should cut down on the network traffic that needs to happen there. And then since we'll be doing more requests because of the fact that you have to download more files, like we've started looking into HTTP pipelining, so you should be able to pipeline the requests to get more performance there. And all this stuff we've been working on for about a year now, so it should probably come out in like Bundler 1.7 or 1.8, so it's hopefully sometime this year. Pretty excited about trying to get this stuff out and make things better. So Aaron actually came to me a few weeks ago and told me that the dependency API, we weren't actually gzipping any of the data. So if you can't read this, basically the non-gzip data for a sample query of 3 gems is about 113 kilobytes. And then if we gzipped it, it drops down to 8.3 kilobytes. And he shared with me some other work he's been doing on RubyGems master, and that combined this work, we rolled it out. So now the dependency API actually spits out gzip files if you request it. So we looked at the original for the gem install. It was about like 7 seconds, and he's managed to cut it down to 2.7. And this has been merged into RubyGems master. So hopefully when this gets released, like things will be faster overall as well. And there's been other performance stuff just locally. There was a pull request submitted by the folks at CookPad. And Winston talked about this a little bit, the parallel bundle install. But there was this pull request that came in that we merged in, and we did a bunch of work where we had to fix basically a bunch of thread safety issues in Ruby gems to get this to work as well. And we refactored it to work with both threads and processes. But just looking at like running a sequential install versus one in parallel, you can cut the time about to half. For like in this gem file test I did, it was just the standard Rails, gem Rails, and did a bundle install. I did this in Japan, so getting much better performance there. But overall, like the bundler team is very realized that performance is a feature, and it's not just some afterthought here, and that not everyone lives in America, and you can't base performance off of how well things happen in the States, even though pretty much the whole team is in America as we travel around the world and felt and seen the pain that it is to install these gems. Like performance globally around the world is also equally as important. So hoping to get this stuff out and make it better for everyone out here. That's kind of all I had, so thank you.